Well, hello good people of the internet. Today we're going to be looking at money, JSON marshalling and test directed programming, kind of all in one big batch today. For the money side of things, I want to store them as ints because you have to. If you don't store money as an integer, the floats get mixed up when you try and add money to other money. Something goes wrong, pennies disappear or appear randomly. That causes confusion. But for marshalling and for sending down the internet, I want to see them as £2.37 or 2.37, not 237. So I'm going to write a custom marshalling method for a type money so that I can send it more easily as with a decimal point. The next thing I'm going to want to do is, I'm going to write the test for this first so we can see test directed programming, or I'm going to write the API, then the test, and then I'm going to fill the API kind of thing. So let's start off with vim, and I'm in an open directory, there's nothing in here. So vim main.go, and this is package money. Now all I really want to have, the first thing I need is a string, so I need a type m, and that's an int, right? And then I need some funcs that will work on this. I need a parse m, so this is how I'm going to create an m. And this takes a string. Oops. And this will return an m and an error. And for now, I'm just going to return 0, nil. So that's just a stub that will compile. The next thing I need is a func safe parse m, and again I'm just writing the stubs for the API, and then def and then we'll return just an m. So the def there is for the default, so this one basically guarantees the returned result will not have an error, and you can choose a default if there is an error. The next thing I need is obviously the Marshal things. I get the string method first, so func, and I'm just fulfilling a couple of interfaces here, so m, and this one will be string, and obviously this returns a string. And again, return, it's just a stub right now, because I want to make sure it all compiles. Func m of type m, and this is Marshal JSON, and for that I want to convert it to string basically, so I need to return a string and an error to match the interface which is provided by the JSON, the encoding.json package, right? And this needs to return, for now, again just a stub, and we need an unmarshal JSON, func m. Now this one needs to be a pointer because you need to fill that pointer, so it's unmarshal JSON, and that's a and this doesn't return string, how silly of me. This returns a byte array, byte slice, and this receives a byte slice, and so we need to give that, we'll call that B, and it also receives a it's receiving the object already, it's a pointer receiver. So all it needs to do now is return an error. Because obviously when you call JSON.marshal, it receives the array and a pointer, and then it will call its unmarshal JSON method if it has it. So, and this just needs to return nil for now. It's not going to do anything with that. these are just stubs. So let's get on and write our tests so we know what these things are aiming to achieve. So I'll call it string test.go, and it's also in package money. And we've got a couple of tests I want to write. The first test is test stringer, so test the string interface. And this takes a t, which is a pointer to testing.t, and doesn't need to return anything, so that's a valid stub, and it will pass, right? And we need a func. I want to test parse t pointer to testing.t. Func. And the other thing I want is a test Marshal. Okay, and that also is a test of pointer to testing.t. And for now, these don't need to do anything. So now if I go over here and I write go test, we'll do it -v dot dash dot dot dot. So v for verbose. So now it'll run. Hopefully it will just compile. Nope. Cannot use type string. Oh yeah, of course. So that was a mistake here, because of course that actually needs to be an empty byte array. Okay. So they've all successfully passed, but they are not any good. They have no use to them whatsoever. So let's create our test methods first. So what do we want? A test struct colon equals a slice of struct, or test slice, I guess. A slice of structs, and the structs will contain, and this is stringing it, so they will receive an M, and they will need to return, they will need a string value to compare them with, right, if we're going to test the string. And let's get some examples together. So 0 needs to return 0.00. That makes sense, I hope, to most of you. If we have 1, I would like to see 0.01, because we're working as these as pennies, right? So if we have 1 penny, that's 0.01 pounds. If we have -1, we need to test the minuses. 0.0, oh, because I want to get the minus 0.01. And there's a bit of a challenge with this one, because if you just do a convert integer on the 1, you're going to get -1. So you can't just stick 0.0 in front of it. So we'll need to make sure that the minuses appear in the right place. 1, let's try 1, 2, and -123 should equal -1.23. We should, no, I can't really test any other examples. Let's try a 100 as well, so we should get 1.00. If you can think of any other cases that I've missed that might be tricky, or any longer ones, let's do a longer one. But if you can think of any that would be helpful for my testing purposes, then please put them in the comments. So the next thing we then need to do is we're going to loop through this. So for _v colon equals range ts, and then os outstring, no, we can't call it os, call it ss colon equals v dot m dot string, right? We call it, that's the method that we've given to it, and this should return if s does not equal v dot s, then we have a problem. We need to t.log f with %d. I'm going to do these as integers for proving the point, with %d expected, and then these will be %s got %s, right? And so it's with the original number, which is v.m, and we'll make it int. Actually, I probably don't need to do that. Let's try it as v.m and see what happens. v.m, and for the strings, so it won't call its string method if we're doing it as a -d. It will hopefully call its integer method, or how to output an integer. The next thing we need is the expected is v.s, and the got is ss, and t.fail and if that doesn't fail, then we pass the test. So now we run this this test. Let's hope there's no compiler errors. So with 0 expected, so yeah, I didn't need to change that. With 0 expected 0.00 got empty string. All right, it returns the empty string. That's exactly what I expected. We're just writing the tests. We don't have the code ready yet. So that's perfect. Actually, I'm very happy with that. Now we'll do another test for parsing, and it's basically the reverse of all of these and a couple of others that get an exception. So we'll copy these. But in this case, for this struct, we need a couple of other things, and I really want the s first. So and e, and I make that a bool. So should there be an error? Okay. And what we're going to do is we'll swap these. So 0.00 should return 0 and false. There shouldn't be an error for that one. Got to remember to learn all my Vim tricks, right? No. So in theory, these are all correct. But we also need some failed tests, don't we? So what if someone just says hello? What should our response be? Well, it should be a 0, and there should be an error. Exactly what the error is doesn't matter, but there should definitely be an error. What if someone puts 23 point? Can we handle that? I think we should be able to handle that, and I think we should get 2300. And that should be a false. There should be no error. Again, if you can see any other edge cases, please let me know. Stick them in the comments, and I'll probably stick them in the code. Anyway, the next thing we need to do is loop through these. So for this one might be handy actually to have. Yeah, I'm gonna take a k and a v. I tend to use k and v, which is key and value in my mind. Range through ts, and so we now need to pass m on. So colon equal comma error colon equals pass m on. What are we passing m on? V. Okay. No, not v. V dot s. And then if does not equal v dot m, we have a problem. Our expected results don't match. So now we want to print t dot log f with expected, then d got %d. So we're taking them out as integers because I want to see what the hidden integer is underneath. Yep. And the internals on that, it's starting with v.s, it's expecting v.s, m, and it gets mm. So if they're not as expected, we get that, and of course t dot fail. Next, mm. Oh no. The other thing we need to check is if the error is there. So this is going to seem a bit convoluted, but bear with me. If error does not equal nil, so if there is an error, is not equal to ts v dot e. Now I realize I could do if error equals nil is equal to v dot e, but I kind of like it this way because I normally work on if there should be an error. So it's if error is not equal to nil, that means there is an error, and if that is not equal to the error expected, then we'll return. That's, I know it seems a bit convoluted, but I think it's probably slightly clearer that way round. And in that case, we need a t.log f expected. Oh, I'm gonna put a line number on this, which is why I needed the k. Line k, oh no, %d with sent as comma airline expected. I think you can do a %b to get a boolean. Maybe I'm wrong on this. We'll see what comes out. Expected b got. I think you can do a %s on an error and it will just work. So first the line number k with v dot s expected a boolean which is v dot e got, and hopefully that should be, well, we'll put error, right? And obviously if they don't match, t dot fail. So in theory we now have a test for that, and let's see what happens if we run it. We should get some failures. So here we expected an error, but we got 0. Yeah, those are the numbers. It's funny, there's only one case and it seems the wrong way around. That one should have an error, expected true, but I got no. Oh yeah, that's right, because it's just returning no error right now. So yeah, that's complaining. It seems to be complaining in the correct places for unworking code. So I'm going to leave that one, and the last test is the test of marshalling, and so we're going to create an array of money with similar values to all the ones we had before. So ts colon equals a slice of m, and the contents of that will be 23. No, let's do it in order. 0, 1, minus 1, 12, minus 12, 123, minus 123, 1, 2, 3, 4, minus 1, 2, 3, 4. Okay, any more ideas for what we need to stick in this test? Obviously, they're going to have to be numbers in the end for this test. Let's leave it there. And what we're going to do is we're going to do that's the Marshal bit, colon equals json.marshal ts, and it returns, when you marshal, it returns that and an error, right? If error does not equal nil, t.log error, t.fail. We'll do a fail now there, because if it didn't marshal, then we got a problem. And then we're going to create var t2, and that is also a slice of m. and then we're going to do error equals json.unMarshal on T2. No, on the data, which is and on T, which return, and we send it a pointer to T2, right? So that it can throw in the appropriate stuff. Again, let's do that. Okay, and then it will loop through for our k comma v equals range T2. Oh no, I'm going to range through TS. It doesn't actually make any difference. If T2 at k does not equal v, then we have a problem. T.log with T2.k with percent %d and got percent %d, and we'll do that as T2 K, and this one should be V. Obviously we fail that test, so T.fail. So I believe I've written the tests that I need to see if this works. We should have a new set of tests. So yeah, we failed now on JSON error calling Marshal for type money, unexpected end of JSON input. Oh right, yeah, okay, because the no, it doesn't completely make sense to me, except that they're not outputting any string at all, and I think that might be the problem. So I reckon, I won't worry about that right now. The point is, it fails all of those tests, and it won't work. It won't get through them until it passes all those tests. So let's try the stringer test. String for s colon equals. No, we don't need that. S colon equals str that's string convert dot, and no, I always get this wrong way around, so let's hope it's right. A to I of. No, it's the wrong way around. I to A of, so it's taking the integer and returning a string, right? So int to whatever A stands for, that seems to represent string. S, no, it takes M, but it needs to be an int, because M is currently money, so we need to convert it to an int so that it will be happy to take that. And now we have basically our string, whether it's positive or negative, we have that. Couple of caveats actually, because this won't work well with the minus. I'll show you what I mean. In fact, let's get it working without the minus, and then we'll see. Here, switch len of s, and so my hope is that this will work with all the positive tests. Okay, so with switch len of s, if case of 1, right, you're never going to get a string of less than 1. So if we get a string of exactly with a length of 1, then we need to return 0.0 plus s. Yeah. So in theory, you're getting a one-digit number, and I think that is actually safe. Case 2 actually doesn't quite work in this case, but that's okay. Return 0. plus s. I'm actually going to break there. I'm going to come out on the bottom, because in those cases it's returned. So here we can return s at len s minus 2 to end, no, up to length of s minus 2 plus dot plus s at, and then it's a slice again, so it's len of s minus 2, and this time we put the colon afterwards. And I think that this will answer many of the test cases. So if we looked at the tests on the first one here, we got all of them failed. Now if we run this again, and we go back up, and we go back up, only a few of them failed, okay? Some of the minus ones actually succeeded, but some of the with minus 1 we expected that, minus 0.01, and we got 0.1, which is a bit dodge. And same with minus 12, but actually if it was bigger than the number, then it actually passed the test anyway. So there's only a few cases where we need to really worry. And that's if its length is 2 or if its length is 3 and the first character is a minus, right? Because if it's longer than the decimal point, it's going to handle it correctly anyway. And if it's only got one length, then it can't fail there. So, that in mind, we can do a simple if s at 0 equals, right? And return, yes, and then we can do this, return minus, now it's got two characters here, so that's a one character with a minus, 0.0 plus s. I think you can actually just get away with that. I was going to slice it on 1 to end, right? But actually, because we know its length is 2, we can actually just do that 1. And there is another case, right? Case 3, and again, if s at 0 is equal to this. Now, I think if we were going to do it longer, we could probably do it more. We probably need to use a fancy loop. So, but with only 3 cases, it feels easier just to handle it here. So if it's 0, then we return minus 0. Plus s and then this we just do a 1 colon, and that will slice it correctly. Oh, I believe it will slice it correctly. Let's have a look and see how the test goes. Oh, where's my mistake there? Cannot convert minus to type byte. Oh, can I do that with these? That might work. Okay, well that got rid of most of them. 23, line 23. Oh, so it's trying to convert that to a byte to add it to that. Why don't we just put a colon on there? And then it's a string. Okay, so that passed the stringer test. Good start, hey? This is almost like a successful recording. How long have I been going? 32 whole minutes. That's ages. All right. Still, good progress. We've got 3 tests written, and we now have the string method, which is one of the hard methods. The only other hard method. Oh, let's write the safe string because. Oh no, we haven't done the parse yet. So the other hard method is parse. And for parse, we need to take a few difficult things, don't we? Like that string could have more problems, could not be a number, and we need to trim it. Let's do that first. S colon equals s dot strings dot trim. Now we need to cut out new line, carriage return, space. Now I'm trying to cut out white space, but I also want to cut out quotes and these quotes because once it's been marshaled, or when we marshal it, I just want to get rid of those things safely. New line, carriage return. What about tab? There we go. We'll just trim out all of those things, and then we know. Did I get rid of space? Yeah, there's a space in there. Get rid of all of those things so we know what we're working with. The next challenge is to handle the minus on the beginning, and the reason for that is pretty much the same. If I do an int convert on the number, I'm going to have a couple of problems handling, because what I'm planning on doing is I'm planning on splitting the number on the decimal point, converting both of the numbers either side of the decimal point, and then returning a string that handles that. So, or at least then putting them together by timesing 1 by 100. If there is no decimal point, I need to handle that, and I need to handle a couple of other situations. So, if s at 0 is equal to, and again we'll just use the minus like that, then s equals, not colon, needs to apply to the real s. S equals s1 onwards, and we need another variable called min equals 1. That's min for minus. So yeah, we'll call it MNS. Just call it minus. Okay, and then minus equals -1, right? There is a problem here. Well, partly that doesn't exist yet, but I don't think that's the problem. Unknown escape sequence. Is this line 8? Yeah, it looks like line 8. So there is something wrong here. New line, carriage return, quote. What if I get rid of those two? Does that? So how do you escape oh, I don't need to escape that one, do I? I can just put that. Yeah, I see why that's red, because it's inside the string. Yeah. I was confused because they were gone purple. Okay, so any of those things get trimmed. Then we check for a minus, and what we do whenever we return something is we'll return minus times it, won't we? Tell you what, let's return here minus times res, and whatever res is. So here we've got a couple of things. The first thing we need to do is we need to split that. So SS, this is my general way of writing a string array is SS, so we'll try that. SS colon equals strings dot split, and we're going to split S on a dot. Now we've got a couple of situations. If SS does not equal, no, if the length of SS is equal to 0, no, it can never do that. If the length is equal to 1, that means there is no dot. So we can return minus times times SS Yeah, we haven't actually done the conversion yet. So Let's do the other big case. There's another much harder, bigger problem. SS : equals strings dots. No, we did that. If len SS is greater than 2, then someone has put 2 dots in this number and we can't handle that. In fact, that should probably be in our test, shouldn't it? What about here it is. Let's make a new one. Okay. Right, and this should return an error. So, in this case, we return 0, errors.new too many dots. Otherwise, we definitely want to do conv, error, equals. No, I'll call it hun and I'll call it pounds actually. Pounds equals, error, equals string convert. Now this one is a, because it's a string, to I of SS0. Now if that is an error, we need to return that error. So if error does not equal nil, return error. Return 0, error. And in this case, we'll return minus times 100 times pounds. So the minus is, if it's minus, it will be a -1. If it's not minus, then it will be positive. So we can just forget that. So in theory, that should answer several of the cases. We still have a few more cases to work on, don't we? So that handles one length. So now we know we have a 2-length array. So pennies equals string convert dot a2i ss at 1. So now that we've got our pennies result, assuming there's no error, if error does not equal nil, we need to return 0, error. Probably should do something with that error, like wrap it. Let's do that. Errors.wrap error could not get pennies. Okay. And this will actually change the package that we're using at the top right. So it was using, oh no, it's still using errors. Oh. I expected that to change the package. We need to get rid of that. And then when we control W, we should get, get the correct errors package. Could not get pennies. So now we are in a situation where we have our actual numbers, but even here we got a small problem, because 1 and 1 will look like 1 0 if it converts. If you've got 3.1, that's going to convert to 3 and 1, so you can't just add it direct. We need that 1 to be a 1 0. So but a 0 1 is correct. So we actually need to use the length of SS So switch, then SS 1. Now there are a couple of cases on this one too, aren't there? If we have, it's still possible that someone wrote maybe 0.133. So case, if that length, oh, there was another error. I wanted to be able to handle I wanted to be able to handle this case. If length of SS at 1 is equal to 0, then that string convert will fail, but I actually want to return the number. Because if someone wrote 34 point, then this would be an empty string, and string convert on an empty will fail, and it will fail, but I actually don't want it to fail. I want to return the same as we did before, return minus, and I'm actually not putting that in the same brackets because my main reason for not sticking that in the same bracket as this is that this one could fail if the length is 1. So it's got to come afterwards, after the return has already happened. We've got a colon before a new line. Is this me trying to do my switch statement? Oh, expected colon, yeah, here we go. So, in this case, we've already got rid of the length 0 case, because that happened up there. So if its length is 1, we need to return minus times result, not res, times 100 times pounds. Now if its length is 1, we actually need to put I'm going to put this in brackets here, and that's plus 10 times pennies, right? Because they're not really pennies at this point. That's the mistake. No, we can actually do it this way. If case 2, and this is why I'm doing it in the switch, return minus times 100 times pounds plus pennies. We don't have to multiply in that case. And the last one is pretty much any other case, in which case we return errors.new pennies too long, too many dp. Alright, now let's try our test on this and see if it now works. We have code not compiling, that's okay. Let's find the first error. No new variables on the left on main 13. Yeah, of course. Main 13, not enough arguments in call to trim because I actually forgot to send it s. Okay, it's 30. Not enough arguments. Oh yeah, to return. So return nil. Probably need a couple more of those. Yep. And that one's correct. Okay, let's see if that gets rid of all of the errors. Can I use minus times 100 times? Oh. There, minus. Okay, so that fixes the M problem. pounds an int? Oh. So yeah, there are a couple of type problems here, but the theory is that this will get rid of the type problems in future, right? Pounds and pennies, they're both kind of ints there, so I can actually just put m here, and that will solve those two cases. Okay, it failed in one case. Oh, let's look at that test case. Silly me, that should have been a 0. So the failure actually was in the test case being wrong, because 1.2.3 should return a fail, a 0, and a true, right? A 0 and an error. So it's passed stringer and it is passed parse. Perfect. Let's quickly write the safe parse method. The safe parse is actually pretty straightforward. It basically just calls parse. So m : equals I need an error too. M, error : equals parse m on s. If error does not equal nil, return m. Here we return def. Ooh. So that should be pretty. Oh, I got these the wrong way around. If there is no error, we return. If there is an error, we return def. And here we return the result of parse. So hopefully that's fairly clear. I basically just run the parse, and if I find an error, I return the default. If I don't, then I return the parse. So that allows people to get rid of that. So we only have two methods left to write. That's the Marshal and the unmarshal, and these are relatively straightforward as well. Unmarshal, v, error, : equals parse m on string b. If error does not equal nil, return error. Otherwise, dereference m equals v, and that's a value. So the parsing result is a value, but I need to put that value into the pointer. And yeah, and we return nil. So that should be the unmarshaler. And our marshaler calls the string method. So we do s : equals m dot string. Now at the unmarshal point, we got rid of the quotes around if there were any, so we don't need to worry about that. But this one needs to actually put them on. So return, and then it's just going to convert the following string, which is a quote plus s plus another quote, and we'll convert that to bytes, and it cannot get an error, so we just return nil. And now we run the test again, and all three tests have passed. It converts to Marshal and converts back again, which it wasn't doing before. The string works and everything works. So that's one of the nice things about doing the test first, actually, is you can easily see where it's failing and you can find the place where you need to fix. So hopefully that will inspire you to do your development with tests first, and see what you get from that. Yeah, let's just quickly run through the test again and just a quick recap. So in our test, all we need to do is you create a struct, and when you create a struct, you can define its type. So fill in the contents, and there's a nice feature in Golang where you can make those contents without having to write the keyword, whatever the name of the struct would, whatever the struct would be in here. It kind of fixes it because it knows the type from the struct creation. So that's a very efficient way, or very easy to read way, of creating these test structs, which you're only going to use once. The next thing, it just loops through and checks against what we've got. So all of the tests are basically the same. Create the test struct, create the test data, loop through the test data and see if you've got the right result. And then when I was actually writing the parse methods, there are a couple of tricky bits, but largely you just got to go through, make sure it works in each case, and try to get it to pass all of the tests. If you've written good tests at the beginning, then passing all the tests means your code is very probably correct. Obviously, I realise that in exams and stuff, people can train to test and then they fail the other things. But if we get the tests wide, that covers everything. So hopefully that is enough for you guys to just carry on, do some stuff like that. Feel free to use this. I'm not going to put any difficult license. It'll probably just be use as you wish, no guarantees, no promises. So go ahead, take a look. Feel free to make a pull request if you think there's a test that's missing. If you feel like there's some way of doing it more efficiently, feel free. I'd love to see your comments on that. Otherwise, like and subscribe, and I'll see you sometime. Bye for now.